Hello my dear children. Now it's our last lecture of chapter solution. Write down your topic is abnormal molecular mass. It's the last topic after colligative properties. Yesterday we have completed colligative properties along with the numericals, and few numericals I have given to you as a homework. After completion of this, then I will take the NCERT exercise and extra numericals in assignment form. Now topic is abnormal molecular mass. Write down abnormalities in the molecular mass only then comes if solute undergo association. Write down association and underline this word. If solute undergo association in the solvent or solute undergo dissociation in the solvent. Abnormalities in the molecular mass only then comes either the solute associate or the solute dissociate in the solvent. Now one by one I am taking in detail. Write down during dissociation. Next subtopic is during dissociation. You will take the example when NaCl is put in water. Dissociation. I am taking dissociation and association after that. During dissociation, if I take NaCl, put it in water, when I have taken it was 1 mole, but when it go into water, it break up into 2 ions. Now it become 2 moles. It was first 1 mole, now it is 2 mole. This means when anything get dissociated, we know after dissociation number of moles of solute increases. After dissociation, number of moles of solute increases. This is 1 pen. This is my 1 pen. After dissociation, it converted to 2 now. 2. That is number of moles increases. So number of moles increases as colligative property is directly proportional to number of moles. So colligative property increases. Colligative properties increases as colligative property is inversely proportional to molecular mass. That you have seen yesterday when I have taken numericals. Now I am going to show you that colligative property is inversely proportional to molecular mass. So many colligative properties I have taken, that is capital M is equal to small m RT by PV. You can check colligative property is inversely proportional. P is osmotic pressure and capital M is molecular mass. Capital M is equal to 1000 into Kb into small ma by delta Tb into small mb. You can check elevation and boiling point is inversely proportional. You can check every colligative property is inversely proportional to the molecular mass. So if colligative property increases, then molecular mass decreases. Okay? Because colligative property is inversely proportional to molecular mass. So this decrease in molecular mass, write down, this decrease in molecular mass is a abnormal molecular mass. Slowly and slowly it will become very simple topic. You go on writing each and everything. Within 5 minutes the topic get clear. But right now, this is my dissociation. Again listen, NaCl dissociated. That I have taken the example, dissociated into 2 moles. That means we know when anything get dissociated, its number of moles increases. Colligative properties are directly proportional to moles. So colligative property increases. Colligative property is inversely proportional to molecular mass, so molecular mass decreases. This decrease in molecular mass is an abnormal molecular mass. Now take during association. During association. I am taking example. Let I have acetic acid. This is my acetic acid. When acetic acid is put in benzene, it get associated, you can see as acetic acid, CH3 double bond O, it is your CH3 C double bond O OH. Make a diagram. CH3 C and this is your H bond. Now you can see 2 moles of acetic acid get joined. It become 1 mole. First it was 2 moles, but after joining, after associating, it become 1 mole. So that means after association, number of moles decreases. Number of moles decreases. Colligative property is directly proportional to number of moles. So colligative property decreases. Colligative property is inversely proportional to molecular mass. So molecular mass increases. This increase in molecular mass is again abnormal molecular mass, right? So the decrease in molecular mass and increase in the molecular mass is this type of picture is called dimer. Write on it's this type of figure is a dimer formation. Below this diagram you can mention dimer formation. 2 acetic acid joined by H bond like this, CH3COOH, CH3COH. This means after association, number of moles decreases, colligative property decreases, but molecular mass increases. This increase in the molecular mass is abnormal molecular mass. To study the abnormalities, in the molecular mass, scientist vonthoff introduced a factor I. Write down small letter I. Very important. I is a Vonthoff's factor. Now he introduced a factor I in each colligative property. You can write formula at change now. Delta TF is I KFM. Delta TB is equal to I KBM. P is equal to osmotic pressure is equal to I CRT. P naught B minus PS by P naught B is equal to I XA. That means in all of the 4 colligative properties, he introduced I. I is a Vonthoff's factor. Now what is the purpose of this? Now we will calculate I. If the I will come 1, if I will come less than 1, if I will come greater than 1. If I is equal to 1, then you will say molecular mass is normal. No association, no dissociation. If I is less than 1, then molecular mass is abnormal and association takes place. If I is greater than 1, again molecular mass is abnormal, dissociation takes place. So this is your all 4 colligative properties. He introduced a factor I in each colligative property, calculated I. If I is the 1, molecular mass is normal. If I is less than 1, association takes place. If I is greater than 1, dissociation takes place. Now this is Vonthoff factor I. Now sometime the question, theoretically question may come. You can write one of the question. What is the value of I? Write on one question. What is the value of I for K4 FeCN6? If anybody asks you what is the value of I for K4 FeCN6, what answer you will give? It's 4 potassium. It's a 4 potassium ion, and this is one of the ferrocyanide ion. 1. This means 1 this. 4 plus 1, 5. 5 ions. This I is equal to 5. Okay? The solute undergo dissociation to how many ions? It's the value of I. So I is 5 for potassium ferrocyanide. Second question. What is the value of I for K2SO4? So potassium is 2, sulfate is 1. 1 sulfate, 2 potassium. So I is equal to 3. For potassium sulfate, I is equal to 3. For NaCl, 1 is sodium, 1 is chloride. I is equal to 2. Okay, this is all about the theoretical question. If anybody asks you what is the value of I is equal to the number of moles of the solute after dissociation or after association. Okay, so now this is this is Vonthoff factor. We will sooner calculate I. Now I am taking one more thing. Now write down degree of dissociation. degree of dissociation. You may directly learn the formula. Degree of dissociation is represented by alpha. So alpha is equal to I minus 1 by n minus 1. You can learn this formula. There is a little bit derivation which is not in your syllabus, but I will take sooner. If the degree of association will come, degree of association is again alpha. Alpha is equal to I minus 1 by 1 upon n minus 1. 1 upon n, right? Alpha is equal to I minus 1 by n minus 1. Alpha is equal to I minus 1 by 1 upon n minus 1, because after association number of moles decreases. So it is 1 by n. So it's degree of dissociation. In degree of dissociation you apply the formula alpha. Alpha is a degree of dissociation, you put here denominator n. Alpha is a degree of association, you put here 1 upon n. Understand this. Okay? Now students, if anybody asks you what is the dissociation constant, you can write K. K is equal to C alpha scale. K is equal to C alpha scale. And what is C? C is your concentration. You can calculate molality, whatever it will be, put here. So now I will take the numerical. This is all about, and how this formula derived. You can write, for example, AB is one of the solute. It after dissociation it gives ions. Before dissociation it was 1 mole. Before dissociation it was 0. Okay. After dissociation it is N alpha. N alpha means dissociated to number of moles. How many moles? And it is 1 minus alpha. Total moles after dissociation. I is equal to total moles after dissociation 1 minus alpha plus n alpha, divided by total moles before dissociation, it is alpha 1. Make it simple. I is equal to 1 plus alpha n minus 1. Now it's become very simple. It become I minus 1 is equal to alpha n minus 1, and this come alpha is equal to I minus 1 by n minus 1. No need to learn this derivation, right? Just remember the formula. Just remember this formula. Alpha is a degree of dissociation. It is I and this is 1. Just learn the formula. No need to derive it. Okay, nobody will ask you how will you calculate degree of dissociation. Now I'm taking numericals, because in this topic only the numericals will come. Otherwise only little bit is very one word question, that what is the value of I for this. Otherwise a numerical. This is a portion of a numerical. Okay. Now open your NCERT. Open your NCERT textbook. This is your numerical. This is the last numerical of NCERT. Open the NCERT book. It's the last numerical of NCERT. Numerical number 40. Take the numerical number 40. The question is, determine the amount of calcium chloride. Write down. Determine the amount of calcium chloride. Question mark. It is I is 2.47. Question number 40 it is 40. I is 2.47. It is dissolved in 2.5 liter. Solution is 2.5 liter. After that it is mentioned the solution concentration is given and its osmotic pressure is 0.75 atmosphere. Okay, and its temperature is 27 degree. Write down all this. Now let us start the numerical. How will you solve it? Very simple numerical, because osmotic pressure is there. Apply the formula P is equal to ICRT. Today you will not apply P is equal to CRT. Understand? Because the I is given. Because the word dissociation is given. When the word dissociation and association is given, always introduce I. When the word dissociation, association, dissociation constants words are given, always write I in every colligative property. Okay? Now let us start. P is equal to pressure is 0.75 atmosphere. I is 2.47. Concentration is N by V. R is 0.082. Temperature is 27 degree, that is 300 Kelvin. What left to put N? Next, what is N? Next you can apply the formula. It is this and N is small m. by capital MV. Small m is the answer. Amount of calcium chloride is small m. Capital M is 40 plus 71. 40 plus 71 put here. Volume is 2.5 liter. So volume must be in liter and by chance it is in liter. So this is all about, you can calculate small letter m. Small letter m is the answer. Again listen. P is equal to ICRT, osmotic pressure is given, I is given, C is N by V, N is further equal to small m by capital M. Small m is your target, capital M is 111, volume is 2.5 liter and temperature is there. Next numerical is 41. Determine the osmotic pressure. Again they are saying determine the osmotic pressure. 41. I will take 3 numericals of this topic. Determine the osmotic pressure by dissolving 25 milligram of potassium sulfate. Now they are asking determine the osmotic pressure. 25 milligram of potassium sulfate is there. This is the last numerical and it is dissolved in 2 liter water. 2 liter water and it is at 25 degree. Temperature is 25 degree and at the end it is written assume the solution is completely dissociated. The word dissociated is there. So let us apply the formula P is equal to I CRT. It's must to introduce I. Why? Because the dissociation word is given. So introduce I. Calculate P. I. What is I? Now I is not there. You can calculate the I. K2SO4. You know how many ions K2SO4 get dissociated? 3. 2 potassium, 1 sulfate. So write down I is equal to 3. You can write 3. If it is not given, you can calculate like this. 3. Concentration is N by V. You can calculate separately. R is 0.082. Temperature is 25 degree, that is 298 Kelvin. This is your answer. Let us calculate N by V. 3 into small m by capital M and V. Now what is small m? Small m is 25 milligram. You can write 25. Pressure is equal to 3 into 25 milligram, 10 raised to power minus 3 milligram, thus 10 raised to power minus 3. Volume is 2 liter. Capital M you calculate. What is the capital M? It is 39 into 2. Potassium atomic weight is 39. Sulfur is 32. Oxygen is 64. Calculate the weight and put here. Rest is same. R is 0.082 and temperature is 298. So this is all about, this comes to us osmotic pressure. 40 and 41 numericals both we have done. Now I am taking one of the example, or you can say in text, any of you can take. So I am taking your numerical number is, it is 32 now. Open 32 numerical number. Only 3 numericals. If you will do these 3 numericals, then that means your topic is totally clear. This year in CBSE exams, the numerical from the vonthoff factor they have touched. In all the sets, the numericals of the vonthoff factor was there. This is the numerical that I am taking. This type of numerical. Calculate the 32 numerical. Calculate the depression in freezing point. Write down delta TF. Calculate the depression in freezing point. Now it is 10 gram of, one of this is given organic acid. Name is CH3, CH2, CHCl. This is the name. This is the formula given. It is. This is your acid, but it is organic. Remember, organic. It is added to 250 gram water. It is added to 250 gram water, right? The question is Ka is given. Ka for dissociation constant of acid. A for acid. It's 1.4 into 10 raised to power minus 3. It is given. And Kf, it is a molar depression constant. It is 1.86. It's a constant for water. 1.86 Kelvin kilogram per mole. Now question is what they are asking, and the target is what they are saying, what to calculate. They calculate vonthoff factor, calculate the depression in freezing point. Is it okay? This is given. Now what you will do? Because in the numerical there is a dissociation word is there. Dissociation constant. So we'll apply the formula delta TF is equal to IKFN. This formula we will apply. Write down. Why we have introduced I? Because dissociation word is in the numerical constant. So we have applied this. Put the values. You can calculate molality separately. Let us calculate molality separately. You know what is a molality? It was my first topic. Molality is equal to weight of solute into 1000 by capital MA into small mb. You may write here W2 or W1. You can mention it is your capital MB. This is your choice. Either you take 1 for solvent and 2 for solute, or you take A for solute, B for solvent. This is your choice. This is your mass of solute. Write down 10 gram. Into 1000 by capital M, calculate the capital M of this. 12, 3, 12, 2, calculate the capital M put here. Very simple to calculate. And what is small mb? 250 gram water. 250 gram water. In this way you calculate molality. Molality is equal to mass of solute into 1000 by capital M into mass of solvent. No need of these two. We have calculated molality. Now after calculating molality you put here, right? Whatever your molality come you put here. Now what is your Kf? Kf is directly given. It's 1.86. And what is your delta Tf that you want to calculate? The question is how to calculate I now. How to calculate I now? Because Ka is given. So what you will do now? Write down Ka is equal to C alpha square. Alpha is equal to under root Ka by C. You will take the help of Ka like this. Ka is equal to C alpha square. Alpha is equal to under root Ka by C. So it's under root Ka 1.4 into 10 to the power minus 3 by C for concentration. Concentration is molality here. Whatever the molality you will calculate, you can put here also. Right? 2 times. Here you can, here you can. So concentration is the molality because we can express the concentration in various terms. So after calculating alpha, now how you calculate I? This is the help we have taken from Ka. Now no need of Ka, no need of this. Alpha is there. Alpha is in your hand. Apply the formula that is alpha is equal to I minus 1 by N minus 1. Apply this formula during dissociation because it's a dissociation word is given. Ka is a dissociation constant of acid. Put your alpha here. Calculate I, and what is N now? N is the number of moles of acid after distillation. 2 it is. How this 2 comes? Every organic acid dissociated into 2 moles. That is organic acid, like you can say very simple organic acid, you can check. Let I have acetic acid. Okay. After dissociation, it forming acetate and HI. This is my 2 moles. So N is 2 for organic acid. So for this acid again N is 2 because the acid name is quite lengthy, but N is 2. Put N is 2, calculate alpha and write, and what I comes you can put here, your question comes. So that means what formula you applied here 1 by 1, that type of numerical was in CBSE this year. You applied delta Tf is equal to I Kfm. In this numerical you applied this. For I you applied the formula alpha is equal to I minus 1 by N minus 1. From here you have calculated I, but alpha was not there, then alpha is equal to under root K by C. This formula you applied because Ka was there. Right? Molality you separately calculated. This type you go this and this. First this, second this, and third this. In this way we moved. First alpha is equal to under root K by C. Concentration molality is separate. After calculating alpha, put here. Okay? Then I you calculate and put here. Kf is here, molality is here. This is the way. And my dear students, it's must to do the numerical number 30. This is your numerical number was 31, and kindly attempt the numerical 32 and attempt at your own numerical number 33 surely, and 2 examples. There are 2 examples, solved examples, but they are solved in a very typical way. So my request to all of the students, kindly solve the examples in a very simple way like that I have taken. I am taking one of the example. In this side you can, there are 2 examples are there, but they are in a very difficult way they are calculated. So please, now I am going to share one example. I am taking example number 13, open. 0.6 ml acetic acid, write down. This is my last numerical, 0.6 ml of acetic acid. In last example, I am taking in a very simple way. Having density is 1.06 gram ml. Write down density 1.06 gram per ml. Write down in bracket, density of the solution is given. Dissolved in 1 liter water. You write everything. First make a table. 1 liter water. Depression and freezing point is 0.0205 degree. 0.0205 degree. It is depression and freezing point. The question is calculate vonthoff factor I. Calculate vonthoff factor and calculate dissociation constant Ka. Very simple. No need to see how they have solved the example. Do yourself. It's very simple. Now first of all, students calculate the molality or directly calculate I, K, whatever you want. Write down. First of all, write down delta TF is here. Delta TF is equal to I KFM. Delta TF is equal to I KFM. Now calculate I from here. After calculating I, calculate alpha and calculate Ka. I'm writing delta TF is 0.0205 degree. 0.0205 degree. Degree, put it in a degree. That I told you yesterday. Calculate I. Whatever the Kf is in the numerical, it put here. Kf is a constant. Right? Molality. Separately molality you can calculate. Molality is equal to weight of solute into 1000 by capital Ma into weight of solvent. Because its volume is given, you can convert it into mass. Density is equal to mass by volume, and mass is equal to density into volume. What is the density and what is the volume? You may mention right here. It is 0.6 ml acetic acid. Right here 0.6 ml multiplied it by density. The density is 1.06 gram per ml. 0.6, 1.06. So whatever the mass comes here, put here. It's the mass of solute. Density is equal to mass by volume. Mass is equal to density into volume. So this is the molality. Now capital Ma, because it is acetic acid, so acetic acid is 60. Capital Ma is 60. Now it is dissolved in 1 liter water. Okay. So 1 liter water means 1 kilogram. Because volume of the water is the same as that of a mass of water. 1 kilogram, you put here 1000 gram. Why? Because the density of the water is 1 kilogram per centimeter cube. It's 1 gram per centimeter cube. 1 kilogram per meter cube, 1 gram per centimeter cube. So whatever the volume, same mass, same volume, and it is 1000 gram. Put here 1000 gram. Again listen, molality is equal to weight of solute. It is this. Density is equal to mass by volume. Mass is equal to density into volume. Put here. And 1 liter water. Water is a solvent. 1 liter is equal to 1 kilogram. Why? Because the density of the water is 1 gram per centimeter cube. Same volume and mass. 1000 gram. Now after calculating molality, you put here. It's a molality. So delta TF is here. Now I you want to calculate. Kf will be a constant. And after calculating I, now what you will do? You calculate, we have calculated I. Now Ka left. Calculate alpha. Alpha is equal to I minus 1 by N minus 1. N is again 2 because it is organic acid, acetic acid. Put I here. Calculate alpha. Now what about Ka? K is equal to C alpha square. C is a molality. C is molality. So this is all about very important topic you have covered today. This completed your chapter solution, and rest complete story of the solution chapter, other things I will take in my next lecture, and take 3 numericals at least of this topic. That is one of the example of the same topic and one of the exercise question. You left with only 2 questions, 1 exercise and 1 example. Thank you.